Okay, this is day 2 of review. We're a little bit off because of the scheduling issues with our classroom. So you should be in the library watching this. Hopefully it's not too crazy around here. And nice and easy day today after a tough one, I think, yesterday with the first 2 tests. We're just gonna do the last test today. So the last test is actually the last test you just wrote, the Unit 6 test. So this stuff will not be old at all. It's on the exam, it's on the summative, but just to quickly review, we're going to be looking at series and sequences. So we'll skip or jam this in here as the second day. I think it's the easiest one to do under the circumstances that we're under right now. So watch this video and then try the homework questions from the text or from the sheets provided. Okay, so real quick, using the formula, I don't have the formula sheet in front of me, but well, I do have it in front of me, but not on the screen. We're going to be looking for the 13th term in this sequence. Okay, arithmetic, that goes from 0 to 12 to 24. A is 0, my first term. D is 12, my difference, plus 12 plus 12. Okay, and then I just jam it into the equation, A plus n minus 1 times D, and I end up with 0 plus 13 minus 1, which is actually 12, times 12, which is 144. In number 2, 5th term, this sequence, we're looking here, and I notice it's not a similar difference. It's not a constant difference. It's a ratio. And how do you figure out, how do you go from 3 to negative 3 over 2 and then 3 over 4? Well, you should see that it's multiplied by negative because the sign is changing back and forth. And this is 1/2 as big and 1/2 as big as this. So this is negative 1/2 as my R. A is my first term, which is 3. Jam that into this equation, a different equation. Also from your sheet, you're going to have that in front of you, so don't worry about that. T5 is R to the n minus 1, and that is then going to be negative 1/2 to the power of 4. And if you remember how that works, back and forth, it'll be positive. Okay, so you have a negative sign, but to an even exponent will make it positive. That's 1 to the 4 over 2 to the 4. 1 to the 4 is just 1. 2 to the 4 is 2, 4, 8, 16. So 1 over 16 is this, times 3 gives you the 3 over 16. Okay, you want to find the formula for the nth term of the sequence, calculate the first 4 terms. I changed it to a little typo. I had n plus 7, which is way too easy. So I'm going to change it to n squared plus 7. So T1 is 1 squared plus 7. T2 is 2 squared plus 7. T3 is 3 squared plus 7. T4 is 4 squared plus 7. Very simple stuff there. Number 4, we're looking at this sequence here. We want the general formula here. So we set up like this, and we don't, in the general formula, we don't care, we do care about n, but we don't change it. We just find out what D is, and D is the difference. So how do I go from here to here to here to here? It's minus 4, minus 4, minus 4. A is my first term, negative 2, so that's how I get these. I multiply negative 4 by n minus 1 to get minus 4 plus, minus 4n, sorry, plus 4. And now I have minus 4n minus 2 plus 4 gives me the plus 2, and that is equal to Tn. That's the general term. In this sequence, number 5, same thing. The difference is I don't have a D, I have an R. And I'm multiplying by 2 in each of these. So 8 divided by 4 is 2. 16 divided by 8 is 2. So that's my R. The difference is here I have 2 squared. I have 4 in this. And you'll find it, whenever I ask you this, you're going to find that this, especially it says simplified form, in the most simplified form. I don't know if that's correct English. But 4 can be rewritten as 2 squared. So I have 2 squared and 2 n minus 1. I have the same base. I'm multiplying bases with exponents on them. The bases are the same. So I have 2 squared and 2 n minus 1. So I add the exponents. So it's 2 plus n minus 1. And then I clean that up and I get n plus 1 is my general term. Here I want to find S11. So I just need A. Got it. I need D. It's arithmetic, so I know it's a D. It's plus 5 plus 5. There's my 5. Throw it into my equation in front of off the sheet, and you're good to go. Okay, geometric series, find S5. So I want to find S5. So actually, that should have been S. Oh, that is S11. It's hard to see though. S5 here. So S5, that should be a 5. A is my first term. R, 32 divided by 8 is 4. 128 divided by 32 is 4. So that's my R. There's my equation. Jamming everything in with an n of 5. 8, 4 to the 5 minus 1. And I get 27, 28. Keep going. If the third term is this and the fifth term is that. So we've done this a bunch of times. So this is one of the last questions here. I extend my answer down this way. Okay, so what happens is T3 is this, so that's a 3. So it's a plus 3 minus 1d, and this is a plus 5 minus 1d. Clean those up, and I get a plus 2d, a plus 4d, and that's equal to 11, equal to 9. So I have these two equations here. I call them equation, I'll call them equation, let me be consistent here. That's equation 1 and equation 2. I think I might have messed this up, actually, as far as what I called them later on, but it doesn't really matter. So I take one, I subtract it from the other. So I have minus 9 subtract 11. Just be careful here, because that's a negative here. So that's minus 20. And then I look here, and I have a minus a is gone. 4 minus 2 is 2d. 4d minus 2d is 2d. So I have minus 10 is equal to 2d, and d is negative 10. First of all, does that make any sense? Let's stop for a second here. If the third term is 11 and then the fifth term is minus 9, I'm getting smaller as I go. So a negative d is fine. Then I go back and I sub into 1. Did I sub into 1? I think I might have subbed into 2 here. I subbed into this guy, whatever I call that, 2, I guess. 11 is equal to a plus 2d. Now I know d is minus 10. So 11 is equal to a minus 20. That's a 2, 0, right? 2 times minus 10. That's not any clearer, but that's fine. Bring this over. I get 31 is equal to a, and then I want, don't forget, I want the general term. You got to answer the question that's given, right? So I want the general term. I could also ask you something like this: what's the sum of the first 10 terms? That's a common one. And then you do something like this: s of 10 is, and then use that equation. Figure whatever, plug it into the equation, or n minus 2, whatever. So once you have your a and your d, that's the hard work, is what I'm saying. A and d is the hard work. Then you sub it into whatever equation you're asked. In this case, I asked for the general equation. So a plus n minus 1d, 31 plus n minus 1 times negative 10. Clean this up, and you end up with negative 10n plus 21. Okay, a couple more before we're done. Number 9, find the recursive formula. So recursive formulas, remember those, the ones with tn minus 1. So I write down my, so what's happening here? I have 3, and then I go to 11, and I have 19. Very simple. I'm just adding 8 each time. But now I have to write it as a recursive formula. So T1 is my first term. It's 3. How do I get my next term? I take my previous term, and I add 8. So that's Tn minus 1 plus 8. And does that work? Well, yeah, let me try that. That's 11. And then if I go 11 plus 8, I keep going. That's good. Pascal's triangle is Pascal's triangle. 1, 5, 10, 10, 5, 1. That was pretty deep, I think, what I just said. So this is the power of 5. So I go to the row in Pascal's triangle, and I have 1, 5, 10, 10, 5, 1 is my coefficients. I ran out of room, so that's why I'm going up and down here. But sometimes I find going up and down as opposed to side with the expansion is actually easier. Up to you. And you notice the little pattern here: 1, 5, 5, 10. Sorry, 1, 5, 10, 10, 5, 1. That's from the triangle. Then I just go 3x. So it's this first thing to the 5, right? Because that's the 5, to the 4, to the 3, to the 2, to the 1, to the 0. Okay, I sound like a horrible rapper here, which I probably am. Minus y squared is my second term, so it's minus y squared to the 0. That's what that says. Minus y squared to the 1, minus y squared squared, blah, 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 blah. Clean that up. A little bit of math here. You might get confused here. Let me do a tough one. Let me just show you what's going on here. Let me erase that first of all. So I have 10, and then I have this term is going to be 3 cubed x cubed. So I got to cube the 3 and the x. Okay, so that's what that is cleaned up. And then I have minus y squared squared. So I have to square the minus y and square the exponent here. So I have 2 times 2 is 4 because it's the power of a power. And because it's squared, it's even. So minus y times minus y is plus y. And that's how I get that. So now I have 10 times 3, which is 30. No, that's wrong. Sorry. So 3 cubed, sorry. 3 cubed, one more step. 3 cubed is 27. I have x cubed. I have y to the 4. Okay, so that was times plus y to the 4. And I have 10 here. So forget that 3. So I have 10 times 27. 10 times 27 is 270. X cubed, y to the 4. And that's what, if you can read that, that's what that says. I couldn't make 5s at the start of the year. I still can't make 5s. Now I don't think I can make 3s that well. That's old age. All right, that's it. That's part 2, or day 2, I guess. Part 6, test 6. Review series and sequences. Spend the rest of the class doing the homework for this, and also all the homework from last day. I think there was a lot last day. Then we move on. Tomorrow we move on to tests number 2 and 3, and we finish things up with 4 and 5. Okay. Enjoy the library. Take care. Bye.